Welcome to Learning I Keywords Fast Track Neural Network. Today, we'll explore one of the most exciting technologies behind artificial intelligence. Have you ever wondered how your phone recognizes your face or how Siri understands your voice? The answer is often a neural network. Don't worry, no technical background is needed. We'll break everything down using simple ideas, fun analogies, and real-life examples. By the end, you'll have a clear picture of how these systems learn and why they're so powerful. Let's dive in and uncover the magic behind the machines. Let's take a quick look at what's ahead. First, we'll answer the big question: what exactly is a neural network? You'll see how it's inspired by the human brain but works in a very different way. Then we'll zoom in on the basic building block, the artificial neuron, and see how it makes tiny decisions. Next, we'll explore how neurons are organized into layers, like stations on an assembly line. After that, we'll discover how these networks actually learn, not by memorizing, but by adjusting themselves over time. Finally, we'll look at real-world examples like image recognition and voice assistance, and wrap up with a chance for you to sketch your own network. This journey is designed to be clear, engaging, and memorable. Ready to begin? Let's start with the basics. So what is a neural network? Simply put, it's a type of artificial intelligence that learns by example, much like how you might learn to tell cats and dogs apart by seeing lots of pictures. It's made up of many small units called artificial neurons, all connected and working together. These networks are especially good at tasks where rules are hard to write down, like recognizing faces or understanding speech. For instance, instead of programming every rule for spotting a handwritten 7, we show the network hundreds of examples, and it figures out the patterns on its own. Think of it like training a puppy with treats. When it gets things right, it gets rewarded. When wrong, it adjusts. Over time, it gets better and better. And that's the key. Neural networks don't follow rigid rules. They learn from data. This ability makes them incredibly powerful in today's AI world. Now, let's meet the smallest building block, the artificial neuron. Imagine a tiny decision maker that takes in information, weighs its importance, and says yes or no. For example, picture a student deciding whether to go to a party. They consider, are my friends going? How much homework do I have? Is the weather nice? Each factor gets a weight. Homework might be very important, while weather is medium. Then they add a personal bias. Maybe they're usually outgoing or tend to stay home. Finally, they make a decision. That's exactly what an artificial neuron does. In AI, inputs could be pixel values from a photo. Weights show which pixels matter most, and the output might be cat or not cat. But here's a key point. Neurons don't store answers. They calculate them fresh every time. So even if the same image comes in again, the neuron reprocesses it. This dynamic calculation is what allows flexibility and learning. Neurons don't work alone. They're arranged in layers like stages in a factory. First, the input layer receives the raw data. If it's a photo, each pixel becomes an input. Then come the hidden layers, the thinking part. These layers gradually build understanding. The first hidden layer might detect simple edges. The next might combine edges into curves or corners. Later, ones could spot eyes or noses. It's like assembling a puzzle piece by piece. Finally, the output layer gives the result. For example, this is a smiling face. A helpful memory tip is IHO, just like in-house out delivery. Data comes in, gets processed inside, and the result goes out. And remember, there can be many hidden layers. The more complex the task, the deeper the network, but even a simple one follows this flow. This layered structure is what allows neural networks to handle complicated problems step by step. Now, how does a neural network actually learn? It's not pre-programmed. It improves through practice. Imagine teaching a child to throw a ball into a basket. At first, they miss. You give feedback, throw higher or less force. They adjust slightly and try again. Neural networks do something similar. During training, they make guesses, compare them to the right answers, and then tweak their internal settings, the weights and biases, to reduce errors. This fine-tuning is guided by algorithms like backpropagation and gradient descent. Don't worry about the names. Think of it like tuning a radio. When the signal is fuzzy, you turn the knob a little until it clears up. The network does this millions of times, each adjustment making it a bit more accurate. Over time, it gets really good at its task. And the more quality data it sees, the better it performs. This ability to learn from experience is what makes neural networks so powerful in AI. You might be surprised how often you interact with neural networks. Take image classification apps like Google. Photos can sort your pictures into cats, dogs, or mountains without you labeling each one. How? A neural network was trained on thousands of labeled images and learned the patterns. Or consider voice assistants. When you say, "Hey Siri," your device doesn't search for exact sound waves. Instead, a neural network matches your voice pattern to the wake word even if you're whispering or there's music playing. Another big use is recommendations. Netflix or Spotify suggest shows or songs because a network learned your preferences from past behavior. These aren't random guesses. They're predictions based on massive amounts of data. And behind all of them is the same idea: find patterns, learn from examples, and improve over time. Neural networks don't follow scripts, they adapt. That's why they're at the heart of so many smart technologies today. Now it's your turn to practice. Let's start with a simple sketch. Draw 3 input neurons. Maybe, is it raining? Are friends going? And do I have homework? Connect them to a hidden layer with 3 neurons, then to one output. Go to party. Label each part: input, hidden, output. This visual helps cement the structure in your mind. Next, pick a product you use, like Alexa, Instagram filters, or YouTube recommendations, and think about how a neural network might be involved. What patterns is it recognizing? Faces, voices, viewing habits? No need for technical details, just focus on the idea of learning from data. For a deeper dive, try an online tool like TensorFlow Playground. It lets you watch a network's separate data points in real time, adjusting as it learns. These activities aren't just busy work, they help move knowledge from your head to your hands. And that's how real understanding grows. Let's clear up some common misunderstandings. First, neural networks don't think like humans. They're inspired by the brain, but they don't have feelings, intentions, or awareness. They're more like supercharged calculators that find patterns. Second, no single neuron decides the outcome. It's a team effort across layers, like a committee voting, not a judge ruling alone. Third, these networks don't truly understand what they're seeing. A cat detector doesn't know cats have whiskers or purr. It just recognizes a familiar combination of shapes and textures from its training. Think of it as a pattern matcher, not a mind reader. This distinction is crucial. AI can mimic intelligence, but it doesn't possess it. Recognizing this helps us use the technology wisely, appreciating its power while understanding its limits. Let's review the key points you've learned today. First, neural networks are AI systems inspired by the human brain, but they don't think or feel, they recognize patterns. Second, they're built from artificial neurons organized into 3 types of layers: input, hidden, and output. Remember IHO, like in-house out delivery? Third, each neuron takes inputs, applies weights to show importance, adds a bias, and uses an activation function to decide whether to send a signal. Fourth, networks learn by adjusting their weights and biases based on errors, like tuning a radio for a clearer sound. And finally, they're used everywhere in photo tagging, voice assistance, fraud detection, and recommendations. You now understand the basics of how AI thinks, not with rules, but with learned patterns. Mastering these ideas puts you on solid ground for further learning. Time to check your understanding. Try answering these questions out loud. First, what are the 3 types of layers in a neural network? And what does each one do? Take a moment. The input layer receives data like pixels or sounds. The hidden layers process that data, building up understanding step by step. An output layer gives the final result like cat or spam. Second, if a neuron has 2 inputs, one positive and one negative, which might have more influence? The one with the higher weight, because weight determines importance. Third, why can't a neural network give perfect answers right away? Because it starts with random settings and needs training, lots of examples, and feedback to adjust its weights and biases. If you can explain these clearly, you're doing great. If not, that's okay, go back and review. Learning takes time and every question helps you grow. If you enjoyed this introduction, there's plenty more to explore. One natural next step is deep learning what happens when we add many more hidden layers. This allows networks to tackle complex tasks like translating languages or driving cars. Another direction is understanding training in more detail, learning how algorithms like backpropagation and loss functions guide the learning process. You might also explore broader topics like machine learning, which includes other AI methods beyond neural networks. And don't forget data preprocessing. Before data goes into a network, it often needs cleaning and formatting. For hands-on practice, try tools like Teachable Machine or TensorFlow Playground. They let you train simple models in your browser. And consider joining beginner-friendly communities like our Learn Mechanelia on Reddit. Learning LA is a journey, and every step builds on the last. You've made a great start. Keep going. To really master neural networks, try these learning tips. First, practice explaining one concept aloud every day, like teaching a friend. This forces you to organize your thoughts and use simple words. Second, draw sketches often. A quick diagram of layers or neurons can make abstract ideas concrete. Third, connect what you learn to real apps. Every time you use Face ID or get a playlist suggestion, remind yourself that's a neural network at work. These habits build strong, lasting knowledge. And don't rush. Revisit this material after 1 day, 3 days, and a week. Spaced repetition helps move information from short-term to long-term memory. With consistent, active practice, you'll not only understand neural networks, you'll remember them. Congratulations, you've made it through the neural network fast track. You now understand what neural networks are, how they're built from neurons and layers, and how they learn from data. You can explain their role in everyday tech and even sketch a simple network yourself. This is a big step in your A journey. Remember, every expert was once a beginner just like you. Keep asking questions, keep practicing, and don't be afraid to dive deeper. Whether you're learning for fun or a future career, you've built a strong foundation. Thank you for your time and curiosity. Stay inspired, keep learning, and who knows, maybe one day you'll design the next breakthrough AI. Until then, take care and happy exploring. Thank you again for joining this fast track session on neural networks. To keep learning, here are some excellent resources. Try TensorFlow Playground. It's a free, interactive website where you can see neural networks learning in real time. Or explore Teachable Machine by Google, which lets you build simple AI models using your camera or microphone, no coding required. For reading, consider Artificial Intelligence, a guide for thinking humans. It explains big ideas clearly without heavy math. And if you'd like community support, check out the our Learn McNeelier subreddit or the AI courses on Khan Academy. All of these are perfect for beginners and focus on visual, hands-on learning. Bookmark the slide and return whenever you're ready to go further. Your AI journey is just beginning. Enjoy every step.